And once again, the following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions, oh, you know what? It's not being shared, is it? Now it is. Ha! The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are 3 different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. You were supposed to tell me you couldn't see it. It's super important. No one cares. All right. Anyway, so today we are going to look at the first part of section 5.8. But before we do that, we're going to answer some questions. And I already have one request. This is from WebAssign number 17 on 5.7. We have the quantity 4b plus 1 squared minus the quantity b minus 6 times b plus 6. All right. So the first thing we're going to do is we're going to apply the exponent, which means we have 4b plus 1 times 4b plus 1 minus the quantity b minus 6 times b plus 6. So we're going to FOIL together the first 2 binomials. 4b times 4b is 16b squared. 4b times 1 is 4b. 1 times 4b is 4b, and 1 times 1 is 1. Combining like terms, we get 16b squared plus 8b plus 1. All right, so there's the first. Keep in mind, order of operations, you do multiplication before.
Yep, I'm on my Zoom meeting right now. No worries.
And we can hear everything you say. Okay. All right. Anyway, so we've got the first 2 binomials multiplied together. Now we're going to subtract this product. So first of all, let's find this product. That's going to be b squared plus 6b minus 6b minus 36. Combining like terms, we get b squared minus 36. But we're subtracting that whole product. I can't talk. We're subtracting the whole product. We're subtracting the whole product. So ultimately, we are going to distribute the subtraction sign through both terms. So the last term ends up being a positive or a plus 36. Any questions so far? Okay. Combining like terms, we get 15b squared plus 8b plus 37. Any questions about that? All right. Any other questions that you have from yesterday?
Number 14.
Can you just tell me what it is?
Yeah, hold on. It was p minus 4q cubed.
So say that again.
P minus 4q.
Is it, what was the first thing you're saying?
P.
P, okay, sorry, I wasn't here. P minus 4 cubed.
And there's a q after the 4.
A q, oh, minus 4q. Like that?
Yes.
Oh, I remember this one. This one's bitch.
Hang on. So P minus 4Q, the quantity cubed. Is that correct?
Yes.
Okay. And that's it? That's the entire problem?
Yeah.
All right. So that's going to be P minus 4Q times P minus 4Q times P minus 4Q. Even though I've got three factors, I'm going to only multiply two of them together at a time. So I'm going to do the first two. Julio, can you turn off your microphone so we're not hearing all the background? Thank you.
I'm sorry.
That's okay. Thanks. All right. So we've got P squared minus 4PQ minus 4PQ plus 16Q squared. Okay. And all of that is times P minus 4Q. But then we're going to take what's in the red brackets and combine like terms, and we get P squared minus 8PQ plus 16Q squared times the quantity P minus 4Q. Any questions so far? All right, so continuing, now we're going to take the trinomial times the binomial. P squared times P is P cubed. P squared times minus 4Q is minus 4P squared Q. And notice I write the P's in front of the Q's. Again, if you keep things in alphabetical order, it's easier to identify like terms.
What?
Lily, turn off your mic, please.
Sorry.
When you come in, please have your mic off unless you need to talk. Okay. All right. Thanks. Okay. So now we've taken P squared times all of this. Now we're going to take minus 8PQ times all of this. So we get minus 8P squared Q plus 32PQ squared. All right. With that. And now we're going to take all of this times all of this. So we get plus 16PQ squared minus 64Q cubed. All right, let's see. We've got some like terms. These are alike and these are alike. So we end up with P cubed minus 12P squared Q plus 48 PQ squared minus 64Q cubed. And there you have it.
That one was definitely difficult.
What gave you the difficulty? Just so much stuff to do?
I think, yeah, I must have just lost myself with all the math.
Sure. And again, you gotta just keep things organized. You're dealing with this first. So again, I went to brackets rather than parentheses so I could focus on doing that, finally getting it simplified,
For me, I think it was the letters, the P and the Q getting squared and cubed and
right.
It was complicated.
Keeping track of the exponents, right? Do you have any questions about that at this point? Okay. Any other questions from 5.7?
So with the after you've already used FOIL for the first two binomials of the equation, then you do it again with the third one. That's what you did?
Well, yeah, you take this and multiply it together to get this. Okay. Then you take that times the last one. And let's say you've got 2 times 3 times 4. Well, what do you do first? You do the 2 times 3 is 6. So you multiply that all together, and then you take the result times the next thing. So just in a bigger sense, we're taking the first two, foiling them all together, and then taking the results times the next thing. Does that make sense, Roger?
Yeah, I was just wondering, But do you not use FOIL the second time?
Well, okay. Here's the problem. FOIL only has 4 pieces: first, outer, inner, last. So if you're multiplying a binomial times a binomial, you're using FOIL. But what if you've got a trinomial times a binomial? You're still using this idea of taking everything from the first one times everything in the second one, but it's no longer FOIL because now there's 6 products instead of 4. So FOIL is more of an idea of taking everything over here times everything over there. So you take the first one times everything over there, the second one times everything over there. Here you take the first one, then the second one, and then the third one. So the idea of FOIL, yes, we're using, but we've actually
Okay.
got 6 pieces instead of 4. Does that make sense?
Yeah, kind of. So the second step is more simplifying it after you've already done FOIL, kind of.
Well, and this is why I personally don't really like FOIL, because of the very thing you're feeling like you have to do that.
Yeah.
I've just got something like this: x plus 4 times x minus 3. I'm going to take this first term times everything over here. So I'm going to get x squared minus 3x. Okay. Then I'm going to move on to the next term and take it times everything over there, plus 4x minus 12, et cetera, et cetera. Okay. So if I've got x squared plus 3x minus 7 times x minus 2, is it FOIL? Well, the idea is there, but I don't have 4 terms. I've got 5 of them, 5, whatever. So I'm going to take this first one times everything, x cubed minus 2x squared. Then this next one times everything, plus 3x squared minus 6x. Then this third one times everything. So literally, it isn't FOIL because I did 6 things instead of 4. But the idea is there. The idea of taking the first term in the first factor times everything in the second factor. The next term times everything. Does that make sense?
Yes, thank you.
Do you folks need another one of these where you've got 3 factors, or are you good to go?
Maybe do one more.
Okay. Do you have a specific one in mind, or shall I just make something up?
Just make something up, it's fine.
All right. Let's say we've got 2x minus 5, the quantity cubed. Okay. So that's going to be 2x minus 5 times 2x minus 5 times 2x minus 5. Again, we've got 3 factors of the base being 2x minus 5. But I'm going to only multiply 2 of them together at a time. So I'm going to FOIL. I'm going to multiply the 2 binomials together. 4x squared minus 10x minus 10x plus 25, which further simplified becomes 4x squared minus 20x plus 25. So we got from there to there, and then ultimately to there. So any questions about that first 2, those first 2 factors?
No, I don't think so.
Okay, now I've got this third factor. Okay, so all of this was equal to that, which is equal to that, and now times the last factor. So 4x squared times 2x is 8x cubed. 4x squared times minus 5 is minus 20x squared. Negative 20x times 2x is negative 40x squared. Negative 20x times negative 5 is plus 100x. So now I've multiplied this by everything over here. So then on to the next one. 25 times 2x is plus 50x. And 25 times minus 5 is minus 125. So now I've done all the multiplication. Combining like terms, 8x cubed minus 60x squared plus 150x minus 125. Are you okay with that?
Yeah. Yeah.
All right. Any other questions? Anybody? 5.7 before we go on to 5.8.
Yes, number 11.
Okay, can you tell me what it is?
It was b squared minus 1/8, and then that's in parentheses, and it's to the second power.
Okay, so b squared minus 1/8, the quantity squared. Is that the whole problem?
Yes.
All right. So we've got two factors of b squared minus 1/8, like that.
Mm-hmm.
So we're going to take b squared times b squared, which is b to the 4th power, because we're adding the exponents. Then b squared times minus 1/8 would be minus 1/8 b squared. Then minus 1/8 times b squared, which is minus 1/8 b squared. And finally, minus 1/8 times minus 1/8, which is plus 1/64. Because multiplying negative 1/8 times negative 1/8, you'd multiply straight across. Negative times negative is positive 1. 8 times 8 is 64.
Okay.
Combining like terms, I get b to the 4th minus 2/8 b squared plus 1/64. Minus 1/8 minus 1/8 is minus 2/8, but I can reduce that, so I get b to the 4th minus 1/4 b squared plus 1/64. All right with that?
I don't know. I could have sworn I tried like a million different ways to enter it, and for some reason I got something wrong.
Okay.
I'm having the same problem, but with
So-
different numbers.
So you're putting in, you think you're putting that answer, but it's not liking it?
I guess I tried like I a lot, and that was the only one that I had issues with. And it just,
Okay.
for some reason it did not. It didn't.
All right.
I
Hang
think I was
on
wrong.
here. Let me see something here. Okay. I am going to pause the recording. All right, and going to go and share this. Okay, so the problem is in your 1/8 times 1/8. Because 1/8 times 1/8 is not 1/4, it would be 1/64. Can you folks see the correct answer that I'm circling right now? With it?
Yes.
Yeah, okay. So the first two terms were correct, but when you took 1/8 times 1/8, it looks like you added them instead of multiplying them.
Oh.
Which is what I think I did yesterday as a mistake doing that. So you've got your 1/4, or excuse me, the 1/8 times 1/8. Does that make sense?
Yeah.
Okay.
So I must have just been confused. I mean.
Yeah, just got to take it slow. Take it slow. All right. Does that clear up that matter?
Yes.
All right. So let's go back here, and we'll get out of WebAssign. And are there any other questions you want me to look at before we go on? Okay, so we're going to go on to the first part of 5.8. We're actually going to spend 2 days on this stuff. Okay, so can you see my working screen there?
Yes.
Yes.
Okay, just making sure. All right, so what have we done in this chapter? We studied polynomials. We learned about the monomials, binomials, trinomials, the degree of a term, the degree of an entire polynomial, the coefficients, all of that stuff. Then we added and subtracted polynomials. Then we multiplied polynomials. So what's left? Dividing polynomials. All right, we're going to start off with dividing a monomial by a monomial, which is actually a review of what happened back in chapter 2. So if you took Math 85 from us, you would have done problems similar to this. And if you haven't, don't panic. I'm going to go through them. What I want to do, first of all, is kind of review some rules that have to do with exponents. Let's say you've got x to the 6th power divided by x to the 2nd power. All right. The rule is that you've got the same base to the top exponent minus the bottom exponent. So x to the 6th divided by x squared would be x to the 4th. And looking at this the long way, that's because you have 6 factors of x on top over 2 factors of x on the bottom. So these reduce out to 1s, and you're left with x to the 4th power. So in general, we get this rule that says a to the m divided by a to the n is a to the m minus n. And we say when you are dividing 2 powers with the same base, you subtract the bottom exponent from the top exponent. Okay? Any questions about that?
Real quick, why is it m and n? Or is that just
That's just
placeholder?
random. That's just what the authors chose.
Perfect? Okay,
Yeah,
thank you.
so just, yeah, okay. Now, let's say we've got x to the 6th power divided by x to the 6th power. Well, that would be x to the 6 minus 6, which is x to the 0 power. But if we took x to the 6th power over x to the 6th power, and we do it out the long way, we have 6 factors of x on the top and 6 factors of x on the bottom. And we go through and reduce them all down to 1 over 1. 3 hours later, we get 1. Well, if x to the 6th divided by x to the 6th equals x to the 0 power, but it also equals 1, that means that x to the 0 power equals 1. So that's another rule. We have a base to the 0 power equals 1 other than 0 to the 0 power, and we don't generally deal with that. But so let's say I've got, y to the 0 power, that's equal to 1. Let's say I've got 428 to the 0 power, that's equal to 1. Let's say I've got 3xy squared all to the 0 power, that's equal to 1. Okay, so we've got a to the m over a to the n equals a to the m minus n, and a to the 0 power equals 1. Now, what if the top exponent is smaller than the bottom exponent? Well, this would be x to the 3 minus 5 power, or x to the negative 2 power, right? Following this rule. But what if we did this problem the long way, and we have x times x times x over x times x times x times x times x, okay? And we go through and reduce it down, reduce it down, reduce it down, and I'm left with 1 over x squared. So x cubed divided by x to the 5th equals x to the negative 2 power, but it also equals 1 over x to the 2 power. So that means x to the negative 2 equals 1 over x to the 2 power. So from that, we get this rule. A base to a negative exponent equals 1 over the base to a positive exponent. Or as students like to say, cross the line, change the sign kind of thing. All right. So for instance, x to the negative 4 power equals 1 over x to the 4th power. We're going to use these three rules in this next section. If you want more review of this, and you've got the textbook or even the ebook, if you go back and look in section 5.1 and 5.2 is where it talks about all of this stuff. Okay, so moving ahead, here is a problem from section 5.8. A to the 12th power divided by a to the 8th power. And it says, divide the monomials. Remember that a monomial is one term. So this would be a to the 12 minus 8 power, or a to the 4th power. And you don't have to write this intermediate step. You can go straight here if you want. I'm just showing how we got the 4. Any questions on that example? All right.
No.
How about this one? 22b to the 9th power divided by 6b to the 6th power. Well, let's take it a piece at a time. Let's look at the coefficients first of all. Okay. 22 over 6, we could divide the top and the bottom both by a 2, and we get 11 thirds. Okay with that? And then b to the 9th over b to the 6th would be b to the 9 minus 6. So we get 11b cubed over 3. Or you could write it as 11 thirds b cubed. Make sure that you don't write it like this. Don't let that b cubed sink down below the fraction bar. It's either in the numerator or it's straight out implying that it's in the numerator, but don't let it be in the denominator in this case, because it should be on the top. We okay with that? I'll take that as a yes.
Yeah, I just had a question about the first one you did when it was x to the 6 over x to the 6. I think you had erased it. It was just a short one.
Okay. So x to the 6th over x to the 6th. Sure. What's your question?
And you said it was x to the 0?
What's 6 minus 6?
0.
There you go.
But what I didn't get, I thought the x's would cancel out too because they're the same. Like
Okay, let me ask you this.
Okay.
What's 7 divided by 7?
1.
What's 7 squared divided by 7 squared?
1.
What's x divided by x?
It would be x. Okay, I get it. Because
It'd
since x is
It wouldn't be x, it would be 1.
It'd be 1. Okay.
So
because x is 1.
No, x isn't 1. X is equal to 1 times x to the 1 power all over 1.
1x. Okay.
So x to the 6th divided by itself would be a number divided by the same number would be 1. Is that making sense?
Yes.
So this is also equal to that.
All right. Okay, thank you.
You're welcome. Okay, here. Let's see. 3y cubed z over 18 y z to the 6th power. All right. So 3 over 18 is 1 over 6. All right. Y cubed over y would be y to the 3 minus 1, or y to the 2 power. Keep in mind, if there's no exponent, there's an implied 1 on it, okay? And then z to the 1 divided by z to the 6 would be z to the 1 minus 6, which is z to the negative 5 power. But I could move this downstairs and make it z to the 5th power. So I've got y squared over 6z to the 5th, or I could write it as 1/6 times y squared z to the 5th. Okay. Now, what I'm not sure about, because some students had issues the other day, if you put a 1 in this form, I don't think WebAssign likes it. So you'd have to experiment with that and see if they, because technically you don't need the 1 there. If you write it in this form, you do need the 1 there. As long as there's something else on top, you don't need the 1 there. It's implied. All right. Okay, so that was the warm-up. That's actually kind of a review with what happened in chapter 2. Okay. Now, we're going to divide a polynomial by a monomial. So that means the numerator is going to have more than one term. The denominator is going to have just one term. So for instance, 6x plus 3 divided by 3. When you are dividing a polynomial by a monomial, the rule is as follows. Take each term in the numerator and divide it by the term in the denominator, creating separate fractions. Then go back and reduce or simplify each fraction. So 6 over 3 is 2 over 1. 3 over 3 is 1 over 1. So I get 2x plus 1 as my final answer. Be okay with this? All right. Let's take a look at another problem. B squared plus b cubed minus b to the 4th power all over b to the 4th power. We have a trinomial divided by a monomial. So we're going to take each term in the numerator and divide it by the term in the denominator. Notice that I carried my signs over to separate the terms. Okay. Now, b squared divided by b to the 4th power is b to the 2 minus 4, which is b to the negative 2, which is 1 over b squared. Why didn't I stop there? Because I want to write my answer with positive exponents. Typically, that's the way they have you do it unless they tell you otherwise. Okay, plus b cubed over b to the 4th is b to the 3 minus 4, which is b to the negative 1, which is 1 over b to the 1, or just 1 over b. Minus b to the 4th over b to the 4th is b to the 4 minus 4, which is b to the 0, which is 1. So the final answer is 1 over b squared plus 1 over b minus 1. Any questions about that? Okay.
Is that how we would enter it into WebAssign?
I believe so.
Okay.
All right. And if it doesn't work, you'll let me know. Okay. 12r to the 15th power minus 48r to the 12th power plus r to the 10th power minus 18r to the 8th power, all divided by 6r to the 10th power. So again, we have a polynomial divided by a monomial. So I'm going to take each term in the numerator divided by the term in the denominator. So I'm going to get 12r to the 15th over 6r to the 10th minus 48r to the 12th over 6r to the 10th plus r to the 10th over 6r to the 10th. Whoops, that's not supposed to be an equal sign. minus 18 r to the 8th over 6 r to the 10th. Okay? So now I'm going to go back and simplify each separate fraction. 12 over 6 is 2 over 1. R to the 15th over R to the 10th would be R to the 5th. So I get 2R to the 5th. We okay with that?
Yes.
Minus 48 over 6 is 8 over 1. R to the 12th over R to the 10th is R squared. So minus 8R squared. Plus R to the 10th over R to the 10th is R to the 0 power, or 1. So I get plus 1/6. Minus 18 over 6 is 3 over 1. R to the 8th over R to the 10th is R to the 8 minus 10, or R to the 2 to the negative 2 power. So this becomes minus 3 over R to the positive 2 power, moving it down into the denominator and changing the sign of the exponent.
Wait, Mr. Mayo,
Yes.
what'd you do on the R10 over 6R10? Let you get the 1/6?
Okay. R to the 10th over 6R to the 10th. So this R to the 10th over R to the 10th is R to the 10 minus 10, or R to the 0 power, which is 1. So this reduces down to 1 over 1. So you end up with 1 over 6 times 1.
Oh, okay. Thank you.
Any other questions there?
No.
And actually, this was the warm-up for what we're really going to look at getting started today. And that's polynomial division, where we divide a polynomial by a polynomial. Easy for you to say, right? Okay. Now, we're just going to get started here today, and then tomorrow we're going to follow up on this section as well. Let's say you've got 485 divided by 7. Okay, what do you do first? Well, you say, does 7 go into 4? No. Does 7 go into 48? Yeah. How many times? Let's see. 5, 6. 6 times? 6 times 7 is 42. Okay. And then you draw a line and you subtract. And some of you were taught to put a subtraction sign, and some of you were taught, well, you're going to subtract anyway. I'm just going to put it to emphasize it. So 48 minus 42 is 6. Since this number is smaller than our divisor, we know that we did that correctly. And we bring down the next term and we start over. 7 goes into 65. Let's see, 9 times. 9 times 7 is 63. 65 minus 63 is 2. And way back in arithmetic, we would have written R2. Okay. Then as we progressed further, oops, I guess that didn't erase everything I wanted to. Later on, we'd say, oh, that's 69 2/7. In other words, we would take the remainder over the divisor and write our answer as a mixed number, unless it came out with no remainder. Okay. Now, I want to take a look at an example of polynomial division. It says divide x squared plus 8x plus 12 by x plus 2. So the x plus 2 is on the outside, and the x squared plus 8x plus 12 is on the inside. The dividend is on the inside and the divisor is on the outside. Okay. Any questions so far? All right. I want to point out some things that are important. This is in descending powers. This is in descending powers. X and then 2x squared, x, no x at all, okay? So we want our dividend and divisor inside and outside both to be in descending powers, okay? So if they're not, put them there before you proceed. Now, I'm going to focus on the leading term on the inside and the leading term on the outside, okay? I'm not going to focus on the whole thing, just the leading terms. And I'm going to take that leading term inside divided by the leading term outside. What is x squared divided by x?
X.
X. So I'm going to put that up there, okay, in the x column. Now, what do you do next? You take this times all of that. So x times x plus 2, which is x squared plus 2x. And you write that here, x squared plus 2x, okay? You still with me?
Yes.
All right. And what do you do next? You draw a line and you subtract that whole quantity. Now, I need parentheses around the x squared plus 2x because if I just put a subtraction sign, it's going to look like it's minus x squared plus 2x, but I'm subtracting the whole thing. Back here, since this is all one term, I don't have to worry about parentheses, but here I do. So the next thing I'm going to do, and we did this back earlier in this chapter, getting ready for this, we're going to change subtraction into addition of the opposite. Remember when we did that? We were subtracting two polynomials or vertically kind of thing. Okay, so x squared plus negative x squared is 0x squared. 8x plus negative 2x is a 6x. And really, I don't even need to write that, but I'm just emphasizing that that canceled out. So now I've got 6x. Bring down the next term and start the whole thing over. And I know some of you are feeling really overwhelmed right now because there's a lot going on. There's nothing new, but it's a whole bunch of stuff in one problem. You will get through this, okay? Now I'm going to focus on the leading term and the leading term. So what is 6x divided by x?
Six.
Is that a positive? No, it's not 6x, it's just 6. All right, because the x is, okay. Is that a positive 6 or a negative 6?
I believe it's a positive 6.
So plus 6, okay? And now we're going to take this times all of that. So we've got 6 times the quantity x plus 2, which is 6x plus 12, which we're going to write up here and draw a line. We're going to subtract that entire quantity from what's up above. But we're going to change it to addition of the opposite. 6x plus negative 6x is 0. 12 plus negative 12 is 0. So I get 0 remainder. So my final answer is x plus 6. So in other words, x squared plus 8x plus 12 divided by x plus 2 equals x plus 6. Was there a question there for somebody? Nope. Okay. How would you check your work? Well, let's go back to this one. How do you check your work? You take 69 times 7, 3, 6, let's see, 48, and then plus the remainder, and you get 485. So it checks. Well, here you'd take x plus 6 times x plus 2, this times this, and you get x squared plus 2x plus 6x plus 12, which is x squared plus 8x plus 12. So it checks. Okay. Let's take a look at another one. Let's say I've got 4x squared plus 6x minus 1 over 2x plus 1. Okay. So my dividend goes inside, that's the numerator. My divisor goes outside, that's the denominator. So I've got 2x plus 1 outside and 4x squared plus 6x minus 1 on the inside. All right, both of them are in descending powers or standard form. So now I'm going to focus on the leading term inside and the leading term outside. What is 4x squared divided by 2x?
2x.
2x. So I'm going to put that up there in the x column. Once we've determined that, then we take this number times all of that. 2x times 2x plus 1 is 4x squared plus 2x. We take the results and we put it up here. We draw a line and we subtract that quantity from what's up above, but we change it to addition of the opposite. So we change the sign of each term inside the parentheses. Now that it's addition, we can drop the parentheses. 4x squared plus negative 4x squared is 0. 6x plus negative 2x is 4x. Bring down the next term and start the process over.
Why do we have to change it to addition?
I'm changing it to addition of the opposite. Because otherwise, if you leave it as subtraction, things get kind of complicated if you're subtracting a negative or subtracting a positive. Think back, let's say we had this. Let's see, 4x squared plus 6x minus 4x squared plus 2x. Okay, let's say we had this problem, which is literally what we have there. Don't you do this? You distribute the negative sign.
Yeah.
Okay, so look at that compared with what I've got there. So
Okay.
if you don't want to think of it as changing it to addition of the opposite, think of it as distributing the negative sign. You still get the same results, or should anyway. Okay.
Okay.
So now, oh yeah, now we're going to start over. Look, leading term, leading term. 4x divided by 2x is 2. So I get plus 2, okay? Which then I take 2 times 2x plus 1, and I get 4x plus 2, which I'm going to subtract, okay? Distributing the subtraction sign, plus, minus, minus. 4x plus negative 4x is 0. Negative 1 plus negative 2 is negative 3. So now I have a remainder. So I'm going to write the remainder. I'm going to go 2x plus 2 plus my remainder of negative 3 over 2x plus 1. And I believe, I don't know about WebAssign, but the author of the book writes it, the answer plus the remainder. So I'm suspecting WebAssign will do that. In other words, you could do this. You could write minus 3 over 2x plus 1, but I think we're going to go with plus, and then if it's a negative number, that. Okay? All right. So get through that first part, monomial divided by monomial, polynomial divided by monomial. If this is still confusing to you, try it best you can. We'll pick it up tomorrow. We'll look at more examples of that and go on to some more complicated stuff within the same section. But anyway, that ends our Zoom session, for today. So I will be back at 1:15 for any of you that have questions, or I'll see you tomorrow.